Spatial arrangements are where many projects begin to encounter difficulties. Historically, the MEP team could often work within an architectural layout that was already well developed. Plant rooms were relatively compact, risers were modest in size, and rooftop equipment could usually be accommodated without major redesign. Under the future building standard, that approach becomes increasingly risky. Heat pumps, larger distribution pipework, thermal storage, increased electrical infrastructure, and rooftop plant all compete for the same finite space. If those requirements aren't considered early, ideally during RIBA Stage 2, they can trigger costly redesigns later in the project. The future building standard isn't just changing building services. It's changing how project teams collaborate from the very beginning. Domestic hot water is another area where design philosophy changes significantly. Many gas-fired systems could generate hot water almost instantaneously, reducing the need for large storage volumes. Low-temperature heat pumps work differently because they produce heat more gradually. Larger thermal stores and domestic hot water cylinders often become an essential part of the overall system strategy. For apartment developments, hotels, healthcare buildings, and many commercial projects, those cylinders can occupy substantial plant room space. Design teams now have to ask an important question much earlier in the project. Where will all of this equipment actually fit? Then there's the roof. For decades, rooftops were often reserved for small ventilation units, lift overruns, and occasional condenser units. Today, they are becoming some of the most valuable real estate in the entire building. Large commercial air source heat pumps require clear airflow, maintenance access, structural support, and careful acoustic planning. At exactly the same time, those same roofs are expected to accommodate extensive solar photovoltaic arrays. Suddenly, the roof isn't an afterthought. It's a carefully planned energy center. These aren't problems that can simply be solved later. If architects finalize roof layouts before MEP coordination, or structural engineers complete framing layouts before plant weights are understood, the design team may find themselves redesigning significant portions of the project. Successful future building standard projects will increasingly depend upon multidisciplinary collaboration from the earliest design stages. Rather than fitting engineering into architecture, engineering becomes one of the drivers shaping architecture itself. Perhaps one of the most significant changes introduced by the future building standard is that renewable electricity generation is no longer treated as an optional enhancement. Solar photovoltaic systems become part of the benchmark used to assess building performance. That changes the conversation from, should we install solar panels, to how do we design the building around them? For electrical engineers, architects, and developers alike, rooftop design begins with energy generation rather than simply available space. Traditional electrical design focused primarily on one question: how much electricity does the building consume? Now there is another equally important question: how much electricity will the building generate? That single change transforms electrical infrastructure. Instead of simply importing power from the grid, many buildings will also export electricity back into the local distribution network. Managing those changing energy flows requires a much more sophisticated approach to electrical design. Generating electricity is only part of the challenge. The local electricity network also needs to accept it. Many distribution network operators already operate in areas where spare grid capacity is limited. That means exporting electricity back into the network may not always be straightforward. Design teams increasingly need to consider battery storage, intelligent controls, and energy management systems, not simply to improve efficiency, but sometimes to satisfy connection requirements. Grid capacity is rapidly becoming another design constraint alongside structure, planning, and architecture. By this point, one thing should already be becoming clear: the future building standard isn't asking engineers to swap one technology for another. It's changing the relationships between architecture, mechanical engineering, electrical engineering, and building performance. And that brings us to perhaps the biggest shift of all: the compliance software itself. Because the days of generous design margins are quickly coming to an end. By rewriting how we handle electrical infrastructure, battery storage, and solar generation, the future building standard completely transforms the physical asset. But designing a low-carbon building on paper is only half the battle. You still have to prove it to a digital gatekeeper that has become drastically less forgiving. Join us for part 3 of this series, where we'll cover why the home energy model and SAP 10.3 demand much greater precision, how small errors in the building fabric or commissioning can dramatically reduce heat pump performance, the importance of accurate product data and commissioning, and the compliance pitfalls that every design team should understand.